Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design lambda by 2 microstrip transmission line. So first we will calculate the width and length of the microstrip transmission line online. In the Google Chrome, enter emtalk calculator emtalk.com. So click on this electromagnetics and microwave engineering. So now here these are the online. So now here I am going to design microstrip transmission line. So click on online microstrip transmission line calculator. So now here we can enter the operating frequency. So now my operating frequency is 5 gigahertz and I will take FR4 substrate. The relative permittivity of the FR4 substrate is 4.4 and I will take height of the substrate is 1.6 and the characteristic impedance is I will take 50 ohm and electrical length is 90. So click on the synthesize. The length of the width of the microstrip transmission line is 3.05 mm and length of the 8.219 mm and the length is not depends upon the characteristic impedance is not depends upon the length of the transmission line, so we can take any length. So now here I am going to design lambda by 2 microstrip transmission line, half wavelength microstrip transmission line, and now the operating frequency is 5 gigahertz. So the wavelength lambda is equal to C by F. So at 5 gigahertz operating frequency, the wavelength lambda is 60 mm. Lambda is equal to C by F. C value is 3 into 10 to the power of 8 meter per second by frequency 5 into 10 to the power of 9. We get the wavelength is 60 mm and lambda by 2 half wavelength lambda by 2 is 30 mm. So the length of the transmission line is 30 mm. I will take the length of the transmission line is 30 mm. So now open HFSS software. So click on the insert HFSS design or go to the project, click on insert HFSS design. So now change the name of the project. So click on the project, right click on this project, click on save as, and my name of the project is microstrip transmission line lambda by 2 and select your suitable location. Okay, and after that first design the ground plane on the above the ground plane we can design substrate. On the above substrate we can design transmission line. First we can design ground plane. So we can draw the ground plane, take the rectangle. So this is the ground plane and double click on this rectangle one, change the name of the rectangle. The name of the rectangle is ground. So choose color, choose your interested color, click on the OK button, click OK button, and after that set the dimensions of the ground plane. So double click on the create rectangle. So now here the position is 0, 0, 0. X position is 0, Y position is 0, Z position is 0, and axis is Z axis. And width of the transmission line is 3.05 mm. So I will take the width of the transmission line is 3. X is the width of the transmission line, and width of the transmission, sorry, okay, ground plane width. So now here the length of the transmission line is lambda by 2 wavelength, and operating frequency is 5 GHz. The wavelength lambda is 60 mm, and lambda by 2 is 30 mm, and the length of the transmission line is Y size is length of the transmission line, that is 30 mm. Y size is 30 mm, length of the transmission line, and width of the ground plane is 15 mm. So once again, so now here I am going to design lambda by 2 microstrip transmission line. Now the operating frequency is 5 GHz. The wavelength lambda is 60 mm. Lambda by 2 is 30 mm. So the ground plane length is 30 mm, and width I will take 15 mm. So click on the OK button. So this is the ground plane. On the above the ground plane, we can design substrate. Now here select the box, and the center position is origin 0, 0, 0. Same size, and this is the Z size. So double click on this box 1, change the name of the box 1. This is the substrate. So now here I will take the material FR4 substrate. So edit FR4, and its relative permittivity is 4.4. So click on the OK button, and if you want to change the color, click on this button, select your interested color, click on the OK button. So now change the dimensions of the substrate, and the center position is 0, 0, 0, and substrate substrate width and length, both substrate length and width are same size of the ground plane, and the ground plane width is 15 mm and length is 30 mm, and thickness of the substrate is, here I will take the thickness of the substrate is 1.6 mm. So click on the OK button. So this is the substrate. So this is the length, this is the width. So on the top of the substrate, we can design microstrip transmission line. This is the substrate. On the above the substrate, we can design transmission line. So take the rectangular sheet. So draw the line, draw the rectangular sheet. So now here the width of the microstrip transmission line is 3.05 mm. I will take the width of the transmission line is 3 mm, and length of the transmission line is 30 mm. So the characteristic impedance is not depends upon the length of the transmission line. So now here double click on this rectangle, change the name of the rectangle. This is transmission line, and choose your interested color. So click on the OK button, and after that double click on the create rectangle. So now here the transmission line position is, X position is uh, now X size of the ground plane is 15 mm. Okay, the X position we will take half of the X size. Half of this X size is 7.5. 15 by 2 is 7.5. 7.5 minus 1.5, that is the X position. and Y position is 0, Z position is 1.6. So that is the position of the transmission line, and axis is Z axis, and the width of the transmission line is 3, and length of the transmission line is 30 mm. So click on the OK button. So this is the microstrip transmission line. That microstrip transmission line is placed above the substrate. First to design the ground plane. This is the ground plane. On the top of the ground plane we can design substrate. So on the top of the substrate we can design microstrip transmission line. So now here the transmission the substrate material is FR4 substrate. So the ground plane and the transmission lines are not assigned any material. The ground plane and transmission lines are assigned by perfect electric boundary. So perfect electric boundary means that is copper. So now click on the transmission line. So right click on the transmission line, assign boundary, perfect electric boundary. Click on the OK button. Okay, perfect electric boundary, and assign the ground plane is also perfect electric boundary. So select the ground plane. So right click on this ground plane, right click on this ground plane, assign perfect electric boundary. And after assigning ground plane and transmission lines perfect electric boundary, this transmission line, this is the microstrip transmission line. So this microstrip transmission line consists of, there are two ports. You can assign two ports. Port 1, you can design port 1 here, you can design port 2 in this place. Okay, this is the x-axis and this is the z-axis. So port 1 and port 2 are designed in YZ, XZ plane. Now we are the first to select the XZ portion. XZ portion. So draw the rectangular sheet. So draw the rectangular sheet from microstrip transmission line to the ground plane. And double click on this rectangular one. So change the name of the rectangle one, and this is port 1. Port 1. So click on the OK button. Change the dimensions of the port 1. Double click on the create rectangle one, and the position of the port 1 is, and exercise is, this exercise is 15 mm. So and this transmission line exposition is 15 by 2. 15 by 2 is 7.5 minus 1.5. So now here I will take same 7.5 minus 1.5. 7.5 minus 1.5 is 6 mm. So this x position is 6 mm, and y position is 0, and z position is 1.66. Z size, height of the rectangular sheet is 1.66, and axis is y axis, and exercise. Exercise is the width of the transmission line. So the width of the transmission line is 3 mm, and the jet size is minus 1.6 mm. So click on the OK button. So this is the port 1. And now select the port 1, right click on this port 1, assign excitation, lumped port excitation, and the resistance is 50 ohms. So click on next button, select the new line. So draw the line from upper port to the lower port. So draw the line from upper port to the lower port. So where this triangle appears, now where the triangle is not appear, so in this position triangle appear. Where this triangle come, click on that point, draw the line from that position to the other end of the port. So similarly on the other end of the port, where the triangle appear, in that position click. So the port is successfully defined. Click on the next button. Impedance is 50 ohm. Click the finish button. So the port 1 is successfully assigned. This is the port 1. Similarly, we can assign second port. So take the rectangular sheet, draw the rectangular sheet from transmission line to the ground plane. Change this rectangle name, and this is the previous one is port 1. Now we have to change this rectangular name is port 2. Click on the OK button. Now change the dimensions of the port 2. So port 2 dimensions are, and this port 2 dimensions are X size X size X size is 15 mm, 15 by 2, 7.5, 7.5 plus 1.5. So 7.5 plus 1.5, 9. So this is X portion is 9 mm and Y portion is 30. So 30 is the X size, 30 mm, and Z size is 1.6. Sorry, not Z size, Z portion. X portion is 9 mm, Y portion is 30 mm, and Z portion is 1.6 mm. And axis is Y axis, and X size is minus 3 mm, and Z size is minus 1.6 mm. Click on the OK button. So this is the port 2. So select the port 2, right click on this port 2, assign lumped port excitation. So click on the next button. So now we'll also draw the new line. So on the top of the rectangular sheet, top of the port 2, where the triangle appears. So where this triangle appears, now where the triangle appears, click on that portion. So draw the line from that portion to the other end of the port. So similarly, other end of the port where the triangle appears, in that portion click. So this port is successfully defined. Click on the next button, finish. And this is a second port. Port 2 is successfully designed. This is port 1, this is port 2, this is transmission line, perfect electric conductor, and ground plane, perfect electric conductor. And after defining port 1 and port 2, we can design radiation boundary. The radiation boundary is bigger size of the structure. The radiation boundary is bigger size of the structure. So now select the XY plane. So draw the rectangular box. Draw the box. So click on this box 1. Change the name of the box 1. And this box name is radiation boundary. And the radiation boundary, we can select the material is air material. Air material. If you want to change the color, click your interested suitable color, and transparency is 0.9. So click on the OK button. And after that, change the dimensions of the rectangular box. So double click on the create box. So now here the X size is 30 mm X size is 30 mm. Sorry, X size is the substrate X size is 15 mm. So bigger than of that size, I will take 30 mm. And Y size is substrate Y size is for 30 mm. So bigger than of that Y size, here I will take 50 mm, and Z size is 30 mm, and this position is 30 by 2 minus 15 mm, and 60 by 2 50 by 2 minus 25 mm, and Z portion 30 by 2 minus 15 mm. So click on the OK button. So these are the dimensions of the ground plane. Now here the Y size is so now here substrate X size is 15 mm, 15 mm. So now here X position I will take 15 by 2. 15 by 2 is minus 15 by 2 7.5 minus 7.5, and Y size is 7 minus 7.5, and Z size is minus 15 mm. X size is 30 mm, Y size is 50 mm, Z size is 30 mm. Click on the OK button. So this is the radiation boundary. So that radiation boundary is the bigger size of the microstrip transmission line, substrate and ground plane. So this is the design structure of the lambda by 2 microstrip transmission line at 5 GHz operating frequency. So now assign the solution setup, analysis setup. So the analysis setup is, so click on the add solution setup. So now where the operating frequency is 5 GHz, and I will select the number of passes 12. Maximum delta S is 0.02. Click on the OK button, and after that right click on setup 1, assign add frequency sweep. Sweep type is fast, and type of the frequency setup is linear count. Select the minimum frequency and maximum frequency. So now here I will take the starting frequency is 1 GHz and stop frequency is 10 GHz, and the operating frequency is 5 GHz, and the number of counts are 101. So click on the OK button. So analysis setup is designed successfully, and after that check the validity. Click on validity. So all are successfully validated, and after that start the simulation. Click on the analyze all. The simulation started. It will take some time. Sorry. Now here radiation boundary is not assigned. So radiation boundary is created, that is not assigned. So select the radiation boundary. Select the radiation boundary. Right click on the radiation boundary. Assign radiation boundary. Radiation. So click on OK button. Radiation only. So radiation boundary is assigned. This is the radiation boundary. So now check the validity, color successfully validated, and after that start the simulation. So click on the analyze all. Okay, simulation is completed. So this is the design of lambda by 2 microstrip transmission line at 5 GHz operating frequency. In my next video, I am showing the simulation results of lambda by 2 microstrip transmission line at 5 GHz operating frequency. Thank you for watching.